We are still on our mitosis. This is still mitosis. In mitosis, we have done our interphase. Now we are going to be considering prophase. This is now what is happening in mitosis now, prophase. This is actually the first step of mitosis. But if you pay close attention, you will see that I don't have prophase 1. I just have the word prophase because this one, it doesn't have prophase 1 and prophase 2 because it's mitosis. What is actually happening in mitosis? That is the question. Remember, we are studying a cytology. Cytology is the study and function of physiology of a cell. We're always going to be talking about cells here. We have our cell now. Now, in our cell, we're going to have our separate tetrad. This is inside, still inside the nucleus. Don't forget, we still have our cell membrane. We still have our envelope. Something nice that will take place here is that we will start to have two centrosomes. We will start to have our two centrosomes. Now, what is our second stage of our, remember they have these centrioles inside. What is our second stage of this particular cell? Our second stage will be that you see here, we will not have this particular nuclear membrane. This particular nuclear membrane will dissolve, will disassemble, will disappear. That's why we will result in having things like this. We will end up having uh, chromosomes aligned in this order. So what's the question? What is the work of this particular centrosome? The work of this centrosome is that they must come and find a good position for themselves here. They must come and find a good position for themselves here. And then this is what is going to be helping microtubule protein structure. This is where mitotic spindle is going to be getting its balance and direction from. So when it is like this, you must just see the difference. Now, here in prophase, at the beginning of a prophase, we do have our cell, we do have our nucleus. But this particular nucleus is an obstacle for this centrosome to work. We can't work if this nucleus is there. Hence, I'm saying once the particular nuclear envelope dissolves, disappear, this is now the centrosome can come down to find a good direction for it, for themselves. Now, can you see here now we don't have order? So if we don't have order, what is going to be taking place here? Mitotic spindles must appear. Mitotic spindles will develop. Let's develop our mitotic spindle. Do you see? But it won't only be these two because these are diploid cells. This inside they are 46. So we will have some, I will explain what is that one, and then we'll have another one, I will explain the different. So this microtubules, sometimes this you can call it microtubules, microtubule protein. This particular microtubule protein, they are going to attach themselves to the centromere of this chromatid of this particular tetrad. But when they attach themselves, because they are not only attaching themselves to this particular centromere, they will also hold, because these are just supporting structure in order for this particular cell to have order here inside. So if they are going to attach themselves right in the middle of the centrosome, we call that is uh, kinetochore protein. So when they attach themselves to kinetochore, we call them that is microtubule kinetochore, meaning that these mitotic spindles will attach themselves to this centromere, resulting in kinetochore. This is a particular protein. But the question is, when it does not attach itself to the centromere, what do we call it? This will be microtubule non. Do you see the difference? If this microtubule will attach itself to the centromere, we call it is kinetochore. If it's not going to attach itself, it will just align somewhere within the chromatid. We call it its microtubule non-kinetochore. So we know this is a microtubule, the mitotic spindle that will not hook the centromere, meaning that this cannot even separate this particular tetrad. This will be the face of your prophase. What is our next step? Our next step is our metaphase. We don't have metaphase 1, metaphase 2, we just have metaphase, right? So what is actually happening in metaphase? Rule number 1 of metaphase, that one you shouldn't forget. We still have our centrosome with centrioles inside. People don't forget that. Ne? We have our centromere that give and support the structure of a tetrad or a chromosome. We have our centrosome. This is the body that enables the cell division. But inside the centrosome, there are centrioles. Now I want us to look at the difference. Can you see the tetrad in prophase? They are not in the middle of a cell, because this was not a metaphase. Do you see in metaphase they're in the middle of a cell? So what is it that will help us to ensure that our tetrad or chromosome are in the middle of our cell? Is what we call is our metaphase plate. What gives the entire cell structure to have order inside, meaning that taking tetrad to line in the middle of a cell is what we call a metaphase plate. But remember, This particular mitotic spindles, this particular microtubule protein, two or three of them will come and attach itself to the centrosome. But there are those ones that we explain that are microtubule non-kinetochore that will not align or that will not attach itself to the centrosomes, but are there in supporting structure and giving strength to those ones that attach itself to the centrosome in order for the pulling apart process to take place. Do you see that in prophase nothing much is happening? The prophase, the metaphase will only ensure that the tetrad are aligned in the middle. So now we are going to our anaphase. What is happening in anaphase? Something nice is taking place there. But the question is that what is it that is taking place in anaphase? Remember, if you are studying a cell, every time you must give us a diagram of a cell. That shouldn't change. That will not change. This particular anaphase rule is known for pulling apart. This is known for pulling apart. We know whatever that must happen here, the particular mitotic spindles will pull apart. This is the beginning of our, this will be our tetrad. We still have our centrosome body with the centrioles inside. And then we know that this is the function of anaphase. Anaphase is known for pulling apart. The cell will begin like this, of course. But shortly after, the cell will be like this now. We're going to have something like this, because this will come and break down this particular tetrad up there. Do you see what is the meaning of pulling apart? These are like, they will come and suspend this particular tetrad, this chromosome. It will be like this. This actually explains pretty much the process of telophase, but we are not there yet. School is so nice. Those who don't know, I feel sorry for them. We still have our centrosome body. We still have our centrosome body. Take it down a little bit. This is a nice work of anaphase. Nice work of anaphase. It's known for pulling apart. Every time when you see anaphase, you must remember that it will come and pull apart. I have already explained the mitotic spindles that does not get attached itself to the centrosome, to the centromere. We understand that they are microtubule non-kinetochore. Those ones who will come and hook the centrosome microtubular kinetochore. So when they are like this, we understand that a nuclear membrane will develop again. Will develop again. I will just give you a structure of a telophase. This was your anaphase. It pulls them apart. So this is now our telophase. This is now our telophase. In our telophase now, structurally, the cell will also change. Do you see? A cell structurally also change. Now it will pull them right at the end of this particular cell. Feel attached to the centrosome. So when they are like this now, do you understand that we already have two identical cells? But we need a process that can divide this totally, not like this, that can give us overall division of this cell. We will have a process taking on this place. The name of that process is known as a cytokinesis. Kinesis has to do with movement. At the end of our telophase, we will have two cells, diploid cell. Don't forget that. As diploid cells, meaning that this side will be 2n, that side will also be 2n. We're going to end up with now another secret that you must not forget is that as soon as this particular nucleus is on this form, a nuclear membrane will reform, will get formed. Can you see that this is a cell? But now, what's the difference? The difference is that if we have our nuclear membrane, we don't need our centrosome, we don't need our microtubule protein, we don't need our mitotic spindles, because this particular cell is a diploid cell, it's complete cell now. This is what I have for you for mitosis. Those of you who study with me will also find meiosis in one of the lecturing. I thank you for watching.